Here is our seventh question. A frictionless wire is fixed between A and B inside a sphere of radius r. A bead slips along the wire. The time taken by the ball to slip from A to B will be. In this picture, you are seeing a big sphere. So AB is a wire and here is the bead. And this bead is now slipping along AB. So the angle is theta, which is given, and no doubt uh, we have to write one more convention. So say which is here. So I can write uh, R here also. So that R stands for the radius. That means this complete length, say this end is C. So AC stands for, so AC is equals to R. So this is the diameter of this sphere. So now what I can do is, we shall assume one thing, maybe something which is missing in the picture. So let us believe this is perpendicular. So and now what I can write is, the thing what we need is time taken by the ball to slip from A to B. So how much time is needed by the bead to slip from end A to end B. So let me first calculate the acceleration along this line. So how much acceleration will be here. So that acceleration I am calculating by means of finding A. So as we know one thing, x is equals VO into t plus half AT square. So this is the thing what we know. So in standards we write like this. So the term x stands for the displacement AB. AB. So let me write AB, which is equals, VO stands for initial velocity of the bead. So VO is 0. So VO is equals 0. Initial velocity is 0, the bead here. So that means the first term vanishes, which is 0. So plus half into, so A into T square. So let me keep this equation here. So now we shall think about the acceleration along AB. So as we know, the acceleration due to gravity along the vertical line, is G. Of course, G stands for some 9.8 or something, which we don't want now. So G, so which is here. So the component of this G along A, that means along AB, is A. So means to say, so the acceleration A is equals, which is a G cos theta. Instead of writing theta, I use the symbol Q. So in my notation, Q stands for theta. So G cos theta. So which is A. So now the above equation AB is equals, which is half into, so A is G cos theta into T square. So this is what we can write about AB. And now what I have to do is, let me think about cos theta. So that I do here. So cos theta. So but say here, but cos theta is equals, so what we usually say, cos theta by definition, we write, by definition, what we can write, by definition, it is the ratio of adjacent segment, length of the adjacent segment, and it is a hypotenuse in the denominator, right? So adjacent divided by hypotenuse. In this picture, the 90-degree mark is here, and this side AC. So this is hypotenuse. So this one, and AB is adjacent. So AB is adjacent. So that means here I can write, right? Here I can write this thing AB is what I can write for adjacent, it is AB, and in the denominator I can write 2R, which is hypotenuse. So now AB is, no doubt, AB is 2R into cos theta. This much thing I can write. So now using this one, this particular equation, AB is equals to R cos theta, here in the above equation, so we will write, say, it is 2R into cos theta, which is equals half into G into cos Q into T square. So this thing I can write. So now definitely something get cancelled, that is say cos and cos. So after leaving, so I can write it is 2R is equals, which is half into G into T square, to T square. Otherwise I can write T square is equals, which is a 4R divided by G, divided by G. So finally I can write T is equals, so T is equals, now root means it is 2, and obviously R divided by G, that should be taken under root. So this answer is correctly said in option A, which is here. So which is here. So definitely this is our right answer. So that's all about this question number 7. So let me take you to the next question. So the next question is here. The next question is this one. So the next question is, a particle is thrown upwards from ground. It experiences a constant air resistance force, which can produce a retardation of 2 meter per square second. The ratio of time of ascent to the time of descent is. So we need the ratio of 2 times. One is time taken by the thing to move up, and another time is the time taken by the thing to move down. So let me first discuss about the motion upwards. So upward motion. So motion upward. So when the motion is upward, definitely the friction, what we call, is acting downward, and obviously G is also acting downward. So the two things I write here, so which is friction, and another one is the acceleration due to gravity, which is G. So in our symbols, always the downward vector is negative and upward vector is positive. So this blue color says motion of the particle, so which is upward. So in this scenario, so we first find the net acceleration. So net acceleration, we shall find net acceleration. So A net, right, A net. So that is equals G, right, G plus frictional acceleration, which is given 2 here. So which is at 2 meter per square second, which is here. So I am using that 2 in my calculation. So which is here. So now this value is a G plus 2, so which is acting downward. So net acceleration is downward. Remember, net acceleration is always acting downward in our situation. Well, so this is the net acceleration. Now I find the displacement made in upward direction. So the displacement made in upward direction is x. So x is equals, so our usual notation is VO into T, VO into T plus half A into T square, into T square. This is our equation. So in this part, so we write x is equals, so x is equals VO into T. So VO is some initial speed with which the object is thrown up, and I call the upward time is T1. So upward time is T1. So upward time I call T1. So in that time, the body moves up, and on reaching a maximum height, it will come back. So T1 plus, that is half, into A is A net. A net is downward, and downward acceleration is always a negative. So means I should take a minus, right? So minus of G plus 2, minus of G plus 2, and G is 10. So 10 means it is of course, so 10 plus 2, which is 12. So I put minus 12 here into T square, to T square. So now x is equals. So x is equals. Oh, what I got is VO into T1, T1, and of course here it is T1, T1 minus it is a 6 T1 square, 6 T1 square, which we must write here. So this is about the upward motion in the beginning. So we found an expression for x, the upward displacement we got. So now I do some more calculation in the same scenario, same situation. So also what I write, it is V is equals to VO plus AT. This is the standard equation we usually follow. So the final velocity when it reaches the maximum height, so that final velocity is 0. So using that condition, it is 0, which is equals VO, and here it is minus 12 into T1, into T1. Otherwise, I write VO, VO is equals 12 T1, 12 T1. So using this condition, this one, VO is equals 12 T1 here. So using that one here, VO, in place of VO I use 12 T1. So what I may get finally is say x, which is a 12 T1 into T1. So say I am substituting only for VO, which is 12 T1, and T1, original T1 is here. So that one more T1 I wrote here. So minus 6 T1 square. So finally x is equals it is 12 T1 square minus 6 T1 square. So that means x is equals 6 T1 square. Square. This is a x for the upward motion. So we got something. Say this is a equation 1. So for upward motion. Meantime, I have to do the calculation for the downward motion. See, when the body is moving downward, the body is moving downwards. So the frictional force will act upward. The frictional force will act upward, whereas the acceleration due to gravity is always downward. So this is a friction. This is friction, and acceleration due to gravity is here. So in this situation, A net is equals, which is 10 means G minus upward friction, which is 2, so which is 8. So this is acting again in a downward motion, downwards. So A net is in a downward direction. So now again I calculate the x. See, be careful when the object sent up, say which is here, so I will show you. So it moves up and it comes back. So when it is moving up, it moves a distance x, and when it is coming down, again it moves the same distance x. So upward displacement is equals downward displacement. This is the key point what I am going to use here. So that x is equals, in this situation when it is coming down, the initial velocity should be taken 0. So when it is coming down, initial velocity is taken 0. So plus half into, so in bracket it is minus 8 into, so the downward time is T2. So this time I'm taking T2. So T2 square, T2 square. So that means x is equals, I can write minus 4 T2 square. So this is equation 2. I already said the both the displacement, upward displacement and downward displacement are same. That means the two equations, equation 1 and equation 2 are equal. So equation 1 is equation 1 is equals to equation 2. So using this condition, what I can write? So one more thing you should remember here, the magnitude of x is leaving this negative sign. So I just use the magnitude of this one. So on this side, so that means what I can write is 6 t1 square is equals 4 t2 square. So finally what I can write is the ratio t1 square divided by t2 square. So that is equals what I can write is which is a 4 divided by, right, it is 4 divided by 6, 4 divided by 6. So which is equals 2 divided by 3, 2 divided by 3. So that I can write. So see here is the ratio what I am finding, this one, this one. So now finally I need the ratio T1 divided by T2. So that is equals under root I should take, so which is 2 divided by 3. So 2 divided by 3. So the ratio what I found is 2 divided by 3. So this is the answer. So T1 by T2 is the root of 2 divided by 3, which is correctly said here in option B. So this is the 8th question. So having completed, let me move to the next question, which is the 9th question. So in ninth question, we are seeing initially car A is 0.5 meter ahead of car B. Both start moving at t is equals 0 in same direction along straight line. The velocity time graph of two cars is shown in the figure. The time when car B will catch car A will be. So we need at what time car B catches A. So this is the situation. So for this we must know something. So car A is moving in the graph like this, it is a line which is parallel to this line is parallel to the time axis. That means the velocity is constant. So velocity of A is constant. Velocity of A is constant. Say some constant. So now the velocity of B is not constant. So velocity of B is not constant. Velocity of B is not constant. So you must know. So this is not constant. So means it is accelerated motion. See in the picture, it is 45 degree here. So that means velocity is increasing linearly. So velocity of B is not constant. Let me find what is velocity of B. Otherwise, I do one thing. Acceleration of B we can find here. So which is nothing but a slope of the curve. So which is equals tan 45. So tan 45 is 1. So means 1 meter per second. So this is meter per second square. So this is the acceleration of car B. And no doubt the acceleration of car A. Car A is 0. So there will be no acceleration in car A. So now what I do is let me find x, the distance, otherwise I say displacement of the car A. So car A is equals, So car A starts from this velocity, which is 10. So which is 10. So 10 into t plus half into the acceleration of car A is 0 into t square into t square. Otherwise, write xa is equals which is only 10t, only 10 into t you can write. So this is equation 1 I call. So next I find xb, so that is equals, so it starts from 0. So the initial velocity of car B is 0. Here you can check. So car B line is here, that curve. So it shows the initial velocity of car B is 0. So that means the initial term in the equation is 0 plus half into the acceleration of car B is 1 into t square Otherwise xb is equals I simply write half into t square. So this is the expression we got for car B, the displacement of car B. So but what we can write is you know at A, that means car A. So car A is 10.5 meters ahead of car B. Initially car A is 10.5 meter ahead of car B. So that means when car B, when car B catches car A at that time, so what I can write is xb is equals 10.5 meter, the initial separation between the two cars, plus the displacement made by the car A. So that I must add. So just on adding these two, so I write something like this. So here I write, so xb is half into t square which is equals 10.5 plus, so xa is 10t, 10 into t, so 10 into t. So this becomes a quadratic equation, which is t square minus 20t minus 20t minus 21 is equal 0, which is equal 0. This is a quadratic equation, is a quadratic equation. So solution for any quadratic equation that you know, so otherwise I write it here. So t is equals, so it is minus b, right? So minus b plus or minus so I can write plus or minus under root. So under root, so you must know this one, under root what I can write is b square minus 4 AC and divide by 2a. So this is the standard solution for any quadratic equation. So I'll make you clear. So in the quadratic equation what we got, yeah, this one, in this quadratic equation, so the term a is 1, the term b is minus 20, the term c is minus 21. So just making the proper substitution of these things in the solution equation, so we will get t is equals, so what I got is 20, so plus or minus 22 divide by 2. So this is the thing what I got. So that means so we will have two options. One is this one, which is 20 plus 22. Okay, so divide by 2. This is the one. Another one is 20 minus 22 divided by 2. Divided by 2. So we got two things. But definitely the answer, this one, this is negative. So let me avoid this one. So for this, so the first one, right? So which is equals, what I can write is, which is 42 divided by 2, so which is equals 21 seconds. So this is our final answer. Okay, 42 divided by 2 is 21 seconds. So our answer is 21 seconds. So which is here. So 21 seconds. So that's all about the question number 9. What you may get. So let me take you to the next question, which is question number 10. Here is question number 10. So in question number 10, position in kilometer, time in minutes. Graph is shown for two cars A and B. Both collide at a t is equals to 150 minutes. Then the distance of position R of the accident from starting point Q of car A will be. So some informations are given. Initial distance between the two cars of 500 kilometer, which is here. Position in the graph shows the distance of the two cars from position Q. Okay, so what we have to find is the distance of point R from the position of Q, initial position of Q. So position is on y axis. Be careful. So position is on y axis and time is on the x axis. So don't make confusion. It is not two-dimensional motion. So the distance what they are asking is this time, this one, this is the question mark what we need. So I call the bottom position here exactly at 150 minutes as yes. So I do one more thing. I simply extend the line PR to some more length here, say here. So the inside angle, so inside angle in any triangle, so this huge triangle, I write it something like T. Here is the line. T is here. Okay, so T is here. T is here, and we shall guess how much is this angle in any triangle. The sum of all interior angles equals 180 degree. So that means the interior angle is this is 180 degree minus 127. So that means T is equals angle T interior angle, that is equals to 180 degree minus 127 degree. So here in my notation, this angle what we are finding here 127. So this angle should exist here as the exterior angle. So 127 degrees here, and I call this angle as theta, and in my notation theta is Q. Theta is Q. So Q, which is appearing here. So now let me say the straight line equation for PR is right. So is what I can write is y is equals it is a slope into x plus c. This is our usual notation for any straight line. So now I write t is equals tan q. Q stands for theta into x plus c. C is a y interception which has happened at a point P, which is plus 500. So all distances are in kilometers. So it is this. So now tan q. So bother about tan q. So tan q stands for 120 degree, 127 degree. So Q is equal, so 127 degree, 127 degree. So let me do some calculation here for tan 127 degree. So which is equals, what I can write is sine 127 divide by cos 127. So I can write this one. This is the ratio of sine divided by cos. Otherwise, I can write like this, you know. So the same thing. So which is equals. So what I can write is which is sine of 90 plus theta. Sine of 90 plus 37. Meantime, I can write a cos of 90 plus 37. So this thing I got. So I got this thing. So now what I can write is this is equals, which is equals. So in the numerator I can write which is cos 37 divide by sine minus sine. Be careful, it's minus sine. Cos of 90 plus 37 is minus 37. Cos 90 plus 37 is minus sine 37. So so what I do is this one you must know certain things. Cos 37. Cos 37 is 0.7986. 7986 and sine 37 is 0.6018. So I say I'll make some approximation. So in the numerator, which is zero point 0.8, and in the denominator I write zero point 0.6. So this is equals, finally what I can write, negative sign. This is uh, 4 divided by 3. So this is what I can write now. So the ratio becomes like this along with negative sign. So which is minus 4 divided by 3. So which is tan 127. So now I use minus 4 divided by 3 here in place of tan theta. So y is equals minus, okay, so minus 4 divided by 3, 4 divided by 3 into x plus 500, plus 500. So this is our notation, what we got. So now y is equals, so y is equals, what I do is let me put x is equals 150. So this point, so if x is equals, so x is here, the value of x is time, so time is 150 minutes. If x is equals 150, so then what happens, y is equals minus 4 divided by 3, 4 divided by 3 and into what I can write 150 plus 500. So this thing I can write, so like this, so now y is equals, what finally I can write, y is equals, it is minus, it is a 4 into 50, which is 200 plus 500 plus 500, which is equals plus 300 kilometers, 300 kilometers. So the value of y we found. That means if x is equals 150 minutes, so y is this much, y is this much. That means this height SR, so this is equals actually SR. So this is the thing what we want. So in the question itself, we have to find the distance of position R. R is here, R of the accident from the starting point Q. So distance means this vertical height, it is position. So vertical height is what we got as SR is equals 300 kilometers. So this answer is correctly said in option B. So this is the correct explanation of 10th question.